we are splitting up each and everything. So each and every topologies into different groups. For example, take your family friends or Facebook friends. So we'll be classifying them upon the based on the community. For example, if you see them in the road, or if you see them in the family, like that. So we'll be disordering, or we'll be separating or segregating each and everyone based upon the characteristics. So this might be like this one. So these are the examples of this assortivity. So these are the three graphs: associativity ups and random and disassortivity. In exam, if they ask about assortivity, try to explain this type this explanation in bullet points. So it will be fine for you. Enter the English letter. So how do we detect the links in the? So we have detected in the uh, network relationship based upon the edges as well as the site percolation. But coming to the associativity, what will happen? We don't know which edge has been attached, or which edge has been which node has been a new node. But based on upon the number of edges between the nodes with the connectivity, we'll be removing those nodes. So that what we'll be doing an assortivity. So detects the preference in the linking of the nodes to each other based upon the connectivity. So how will be removing those, or how will be identifying? So we detect preferences in linking of nodes to each other based on their connectivity. Or we'll be measuring the distance between them, or we'll be finding them based on the some property, that is, it is a randomized network, right? So in a randomized network, we will be don't knowing that which node has which type of characteristics, all those. So we'll be removing the nodes based upon the same property characteristics, or the number of edges, or the degree distribution it has, or based on the clustering coefficients, all those. So measure n of k0 comma k1. So where k0 and k1 are the different nodes. That is the number of edges between nodes with connectivities k0 and k1. So we will also compare the characteristics of the nodes. Compare it to n randomized network of k0 comma k1. That will be seen that it also have the same property or not. Same property in a properly randomized network. So that is what we'll be doing in assortivity. So we are already calculated the degree distribution, right? Average degree. So based on the average degree distribution, we'll be trying to find the assortativity. So here in assortativity, we'll be seeing that we'll be finding the correlation between the two nodes. So if the correlation is high, we will be finding that, so this node is very much important for us. If the correlation is low, we see that it might lead to the failure of the network. So we'll be removing based upon the correlation of degree of I versus I node, or degree of J node, or over all edges, that is I comma J. So we are talking about the social network, right? So what is the correlations or Pearson correlation coefficients of the internet? So the internet is a, so what is an internet? Internet comes under which type of assortativity? So comes under associative ups, or randomized, or distorted ups. So the internet comes under the distortivity ups, because we don't know that how many person will be creating its own network, right? So it is not a randomized network, but we'll be will be in a disordertivity network. Why? Because for example, if you are using a LinkedIn, you are the one you are using, you will be trying to send a request to your friends. So these are the group of your friends. Then later will you try to send the request to the company CEOs. So from company CEOs, you will be sending a request to is mutuals. So from each mutuals to each mutuals. So LinkedIn is one of the best example also. So internet is the best example of this activity. So the internet is this assortative disortative. So the Pearson coefficients of internet is equal to minus 0.189. If the Pearson coefficient is negative, that means that if you increase the network on, you will be having a degree. If the Pearson coefficient is in negative, we'll be having a vice versa relation that if one parameter increases, the another parameter will be decreases. That is what Pearson coefficient deals with. Pearson coefficient is nothing but it will speaks about the relation between the two parameters. That is Pearson coefficients. So what are the applications of assortative? So the assortative is not a degree to degree correlations. It also comes under the probability also. So what are the applications? What are the applications? Applications such as social networks like income, gender, age, or food webs like RBORS, ConVORS, OmniVORS, and the internet high level connectivity problems, IP addresses, consumers. So this all comes under the applications of associativity, because we are not only dealing with the degree, but we are dealing with we are dealing with the probabilities also. So what are those? So social networks, that is race, income, gender, age, etc. And second one is the food verbs that what they are there, herbivores, herbivores, carnivores, etc. Carnivores or omnivores. Now coming to the another one, that is known as internet, which has high connectivity, high betweenness and active everything, it is in the internet. So high level connectivity providers are just IP addresses. That's all about the applications. And coming to the degree associativity and resilience, associativity will be having a use connections, and coming to the disassociativity, it will be having a different types of links between them. So that's all about assortativity. So what we have discussed in assortativity is a preference of a network to get attached to others that are similar. So we'll be having a that similar connection between no each and every node. So we'll be seeing these characteristics, and this node will be tried to attach to the node which have the same similar characteristics characteristics. So that is what. So there are three types of assortativity, that is assortative ups, random, and disassortative. So coming to the assortative ups, it has a central mechanism that is known as hub. So every hub will be having different switches. So the new nodes will be coming and joining with the switches. Coming to the random, so there might be also a switch, there might be also an hub, but what will happen, they will be joining randomly without considering the degree or coefficients, etc. What is disassortativity? In disassortativity will be, what will happen is that, so we'll be having a different types of topologies, because we don't know which one will be getting connected to the which one. So then we have discussed about how we should find the edge or the node. So we will be finding the number of edges based upon the connectivity of a k node or ki, or we'll be seeing it in a randomized graphs, that is with the same property or not. So if it is in a randomized manner, so we don't know the which version we are connecting to the, or which node has some special characteristics. So we'll be compare each characteristics as well as the number of degree or coefficients it has. So what are the application? In application, so we have discussed social networks, food verbs, and internet types, etc. So what are the social, race, income, gender? So all those things which have the associativeness comes under all the assortativity. So that's all about for today. Thank you.